Hello everyone. Today we are going to discuss about a few important concepts of cloud computing. So to begin with, let us start with virtualization and then a few other concepts such as load balancing and auto scaling, along with a few case studies. So before we discuss about virtualization, let us have a quick look at cloud computing definition in general. Cloud computing is a model, it's a paradigm for providing on-demand network access to a shared set of resources which can be dynamically configured and can be rapidly provisioned and deprovisioned as needed. And the more important concept here is there should not be any management effort from the user side, or there should not be any interaction with the service provider, or with minimal interaction with the service provider. So if you look at this definition, we should be able to provide resources on demand. We should be able to increase the resources dynamically, or we should be able to remove the resources dynamically when they are not needed. So how is this possible? So one option is to buy the resources. So we can buy as many resources as possible, keep them aside, and we can provision them as needed, and when they are not needed we can keep them away from where they are used. But this requires a lot of capital expenditure. At the same time, it involves a lot of maintenance cost. So obviously this doesn't seem to be a viable option. What is the other option? So the key driver, in fact, that enables cloud computing is to be able to create multiple resources. So we generally have minimal number of resources, limited resources, not unlimited resources. So using those limited physical resources, we should be able to create several resources, multiple resources, particularly on demand. So we have one physical resource, we should be able to make it appear as multiple virtual resources so that we can dynamically provide them as needed. Similarly, we may need to combine multiple physical resources also to create one logical resource. For example, we may have several hard disk drives or solid state drives, each having maybe 1 terabyte or so. We may be able to ask to provide 1 petabyte data, or maybe several 1000 terabytes of storage space. How can we do it? So we cannot manufacture a new disk drive because we are already in possession of several terabyte disks. So we should be able to combine those multiple physical resources so that they can create a larger logical resource or a virtual resource. So in other words, so all these scenarios, if you look at, we need a new technology which can enable the hitherto discussed features. So this enabling feature is known as virtualization. In fact, virtualization is not new, it's not a new concept, it has been there. When mainframes were there is a central mainframe server, there used to be several terminals connected to it. So each terminal appears to the end user as if it were the only, as if he were the only user connected to the mainframe, but it's not really the same because it's virtualized. And so far with the advent of, after the advent of personal computing, virtualization has lost its prominence and internet computing came into picture, cluster computing, and all these things actually put virtualization a bit back. But now with the advent of cloud computing, virtualization has become more popular now. So if you look at cloud computing, virtualization is the key driver behind it. So what is virtualization? Virtualization in general, based on Wikipedia or any other standard resources, it is the creation of a virtual resource, virtual version, in fact, which is not the actual of something. It can be a hardware platform, operating system, network, storage, memory, or it can be anything. So it is a creation of a virtual version of an actual resource or actual thing. So what does it do? It actually makes a physical resource shareable across multiple resources, multiple virtual resources. At the same time, it can integrate multiple physical resources into a single logical resource, which is needed. In fact, cloud computing is totally based on this particular concept, because we need to provide resources on demand. A resource can be a smaller one or a bigger one. So if it is a smaller one, we may need to divide one physical resource into multiple resources. If it is a larger one, we may have to combine multiple physical resources into a single resource. So all these things are possible with virtualization. So basically, it's a broad term. Virtualization is a broad term. It essentially refers to the abstraction of computer resources. Basically, it's hiding the implementation. Abstraction in general, you all know that it's a part of object-oriented programming. So it is essentially hiding the implementation details from the end user. So this is also the same. The physical resources completely abstracted from the end users. He doesn't know where the physical resource really exists. All he has access to is a virtual resource. So hiding those physical characteristics of all the computing infrastructure and providing the necessary virtual resources. So this includes, again, as I said, a single physical resource can be shared across multiple resources, or it can include making multiple physical resources appear as a single logical resource. When I say resource, it can be an operating system, it can be a hardware, in the sense it can be a storage device, it can be a processor, it can be a memory unit, it can be a network interface card, anything. So virtualization actually is categorized into two basic broad categories. One is process virtualization, which we all pretty well know, and the other is system virtualization. Process virtualization is, in fact, most of you, as part of your third semester Java object-oriented program, many have done that. So they know Java virtual machine or Java runtime environment. What does it do? It converts or translates or interprets the bytecode into an executable piece of code, into machine instructions, so that your computer can run it. Every computer has a Java virtual machine. It is a virtual processor. It's a virtual process which is automatically created. So similarly, we have CLR, Common Language Runtime of .NET Framework, which takes the Microsoft Intermediate Language, the compiled version of .NET code, into machine instructions and then runs it. So this is an example of process virtualization. So, but what do we need now? We're not really virtualizing a process. We are virtualizing resources. So we need system virtualization. This is another thing. So process virtualization also involves a software layer. So you create a virtual process under the control of a software layer. In case of system virtualization, you create a virtual system, a virtual machine under the control of a software layer. What is that software layer? What is it called? This software layer, which can create virtual resources from physical resources, is called a hypervisor. It is also known as virtual machine manager or virtual machine monitor. There are several terms, but typically we call it as hypervisor. So this is a software layer which runs, or this is the virtualization software which runs between your physical resources and the virtual machine broadly. So we'll see where there are various types of hypervisors available, and the example players include VMware, very popular product, very popular organization which has its own virtualization tools, and we have VirtualBox from Oracle, we have KVM, we have Xen virtualization. There are so many things are there. And so we have a quick case study also on how to create a virtual machine using VMware Workstation. So we will see that at the end of this topic. So let's go to some of the key concepts of this related to hypervisor. So hypervisor, as we discussed, is a software layer which allows the creation of multiple virtual machines on a physical machine. Okay, the physical machine is known as host machine or host OS typically, and the virtual machines are called guest operating systems or guest machines. And your virtual machine consists of all virtual resources. They are not physical resources. So you have a virtual processor, you have a virtual memory, you have virtual storage, virtual network interface card, virtual USB, everything is virtual. So basically everything is virtualized. So we have only one physical resource, but you have several virtual resources. So there are different types of virtualizations. As I said, hypervisor, using hypervisor you can create virtual machines in multiple ways. The very first one is bare metal. As the name suggests, bare metal. So your hardware, on top of the hardware your hypervisor runs. There is no operating system. So typically what do you do in order to make your computer work? You need an operating system. So without operating system, how can you make it work? So what do we do in this case? We really do not want those physical resources to be directly accessed. Instead, we want several virtual machines to be created on the physical infrastructure. So how do you do it? So you install a hypervisor. So then who will take care of all the operating system responsibilities? Your hypervisor will take care of them. So that's why hypervisor code is very thick. So it has a large number of instructions. So so to start it takes quite a good amount of time. Okay, it has the complete control of the hardware. Okay, hypervisor acts as the resource manager. So it takes care of the complete responsibilities of your operating system, your memory management, I/O management, disk scheduling, everything it will take care. Okay, so using that bare metal hypervisor, you can create several virtual machines on top of it. So you cannot directly access your physical resources. So this is type 1. It's famously known as type 1 hypervisor. So VMware's ES6i is one of the popular and Xen are the popular type 1 hypervisors. The second type, type 2 hypervisor, it is hosted. So as I said earlier, in order to make your physical resources, your computer work, you need an operating system. So you install your operating system. On top of the operating system, you install your virtualization software. So this is hosted. So there is a host operating system running on your physical resources. You can access all those physical resources through your host operating system. On top of that, you are installing a hypervisor. So your hypervisor, on top of the hypervisor, you can create multiple virtual machines. So your operating system will take care of all the activities such as memory management, disk scheduling, CPU activities, all those things, disk scheduling, process scheduling, everything, or your operating system, your host operating system will take care. Your hypervisor is essentially used for creating virtual machines, and it takes care of how to start them, how to stop them, how to migrate them. That's it. It doesn't do anything else. So that's why its code is quite less as compared to the bare metal one. So typically we combine these two things to create multiple types of hypervisors. So as you see on the screen, so we have hybrid type. So it's a combination of both type 1 and type 2. And we have shared. Shared, in this case, some part of your physical resources are used by a host operating system and some part is used by your bare metal hypervisor. So the next slide will tell you, the diagrams will explain you more about it. So this is type 1. So your hardware is there. On top of the hardware, you have the hypervisor. Hypervisor creates multiple virtual machines. In this case, we have only 2 virtual machines, but you can create many. So this is a typical depiction of type 1 hypervisor. So example players include ES6i, Microsoft Hyper-V, Xen. These are popular bare metal hypervisors. The second type, as you see, on top of hardware, you have operating system running. That is the host operating system. On top of that, you have a hypervisor. This hypervisor will create multiple virtual machines. So your disk scheduling, memory management, all the operating system responsibilities are taken care by the host operating system. Your guest operating systems will run on top of the type 2 hypervisor. So some of the popular tools are Workstation, Vmware Workstation, Microsoft Virtual PC, and in fact VirtualBox. It was initially Sun version, Stanford University Networks VirtualBox. After the acquisition from Oracle, it is now known as Oracle VirtualBox. Then QEMU, KVM, kernel virtual machine. So there are several tools are there to create type 2 hypervisors. So hybrid type, as you see, there is so this is a generic case of type 2 virtualization. So you have a host operating system. On top of that, you can create your own processes, so which will make use of the host operating system, and some part is used for hypervisor. The type 2 hypervisor is installed, which can be used to create multiple virtual machines. The fourth type is hybrid. As you can see, so your hardware is shared between host operating system and hypervisor. So these are all possible. So you can create different kinds of hypervisors which can enable you to create multiple virtual machines. Next, what are different kinds of virtual machines? Hypervisors. We have seen different types of hypervisors. Now let's have a quick look at different kinds of virtualization techniques. So platform virtualization, storage virtualization, network virtualization, memory, application, desktop, any virtualization. Because now with the advent of cloud computing, people are talking about everything as a service. Infrastructure as a service, platform as a service, software as a service. The list is not completed yet. You have anything as a service, everything as a service. So obviously we should be able to virtualize everything. Whatever resource we have, we should be able to virtualize it. So any virtualization, I mean in general, that's not a type of virtualization. That's what the essence here to understand is that you can virtualize any kind of resource. So platform virtualization, so as I said, it enables several virtual environments to coexist on a set of physical resources. So you can create multiple platforms, multiple operating systems. So you have a Windows 7 operating system running on your computer hardware. On top of that, you can create a Linux machine, Linux maybe RHEL, Red Hat Linux machine, CentOS machine. You can create another Windows 7 virtual machine. You can create a router machine. So all these things, and you can put all of them into a virtual network, virtual private network. Okay, so we can use this virtualization to create combined environments. As I said, multiple, you can create a network. On your computer itself, you can create a network. So this is possible through this virtualization. Another important feature here is that you can migrate your virtual machines from one computer to another computer. So you can teleport them. You can probably copy your virtual machine files into a USB drive or your hard disk, and then you can put it in another computer. So storage virtualization, this is in fact more important one. So it refers to the process of completely creating a logical storage from a set of physical storage devices. Okay, so this is very famous in storage area network. The other type of storage virtualization is NAS, network attached storage. Okay, so what do we do? So in storage area network, multiple physical resources, physical storage devices are combined to create one logical resource. In network attached storage, one physical resource is divided into multiple virtual resources. So this one particularly talks about storage area network, because we need more and more physical storage, okay, particularly to deal with the social media data. So we need humongous data we have. So how do we put it? Maybe we may need it for some kind of processing, but where do we put it? How do we put it? So we need to be able to combine all these physical resources into one logically very big resource. So this is quite conspicuous in the way we define RAID devices, redundant array of independent disks. It's a set of independent disks. So we combine them into a RAID device, and it provides fault tolerance also. And it can be JBOD, just a bunch of disks. So you have a bunch of disks, you combine them, and it appears as a single logical disk. And the important thing is, you may have several storage devices. They may be scattered across network. One device may be in your local area network, other device may be in some other area. So you can combine all those things, and the end user thinks that it is only a single device. Data center is a very popular place where all these storage area network concepts are prominently used. So this is what it is. So as you can see, RAID arrays. So you have end users, storage virtualization layer is there. So you have a set of disks, you have RAID arrays, you have just a bunch of disks. All these things are combined and they are virtualized to create one logical device. Right. So the other thing is network virtualization. As I said, you can create a network on your computer. You can create a local area network. Do you have more Ethernet cards, more network interface cards? Not really. You have only 1 or 2 network interface cards. But if you want to create a cluster of 16 computers, how do you do it? So you should be able to virtualize your network interface card. So you should be able to create a virtual LAN. So it is the process of creating, again, a software layer, abstraction layer that creates 1 or more virtual networks on top of your physical infrastructure. So this is again categorized into 2 parts: external, which is combining multiple networks into a virtual LAN. So the other one is internal. So the one which we discussed earlier is internal network virtualization. So you create a network-like functionality on your computer just to understand how different kinds of routing algorithms work, how do you set up a routing table. So you can create a couple of networks, or you can probably create 3 or 4 virtual machines on your physical machine, and then you can probably put them in a network. Maybe you can create 2 different LANs and you can combine them using a router, so which is pretty much possible. So that is internal network virtualization. Then memory virtualization. It is memory virtualization, we already know, we have been doing it. In fact, virtual memory is a very popular concept used, but of course it is used for paging on one machine, on a single machine. In this case, we are virtualizing the memory into multiple virtual memory units. That means you may have 3 or 4 virtual machines running on your physical computer. You may have 4 GB of physical memory, also known as RAM, random access memory. So you may want to allocate 1 GB to one virtual machine, 2 GB to another machine, 1 GB to another machine. You may want to distribute it. So how do you do it? So this virtualization, memory virtualization, will take care of that. So this is pretty much similar to the way modern operating systems provide virtual memory virtualization and paging concepts. So, and the beautiful part here is that it can combine multiple physical memory devices into a single logical memory. You may have 4 GB in one machine, 16 GB in another machine, maybe some memory in some other machine. So you may want to combine all those things. It is not possible without virtualization. So you can combine all those things and you can make larger memory out of it. So this is, so basically when we talk about virtualization, there are 2 ways. One is distributing one physical resource across multiple virtual resources, at the same time combining multiple physical resources into a single resource. So both should be possible, and all these virtualization techniques essentially do this. So application virtualization, it is popularly used in software as a service, in wherever SaaS applications you have. So they provide multi-tenant applications. What do you mean by multi-tenant application? So multiple users can access that. At the same time, every user feels that he was the only user accessing the application. In fact, there are multiple users, multiple tenants, they are accessing it, they are accessing the application, but everybody works in isolation and others do not know what you are doing and you do not know what others are doing. So that is the multi-tenancy application virtualization. Application virtualization is used in almost all the software as a service providers, like your whatever SaaS providers we have, all of them are doing all those things. So basically these applications are consumed as a services, multi-tenant hosted model, and the important concept is they provide personalization. So you can personalize your own data, others can personalize their own data, but they are not intermingled. Okay, so desktop virtualization is another concept. So it provides, desktop virtualization is separating your computer desktop environment from the application software and from the physical computer. So basically virtual desktop infrastructure and session virtualization are 2 important concepts which we used to use in mainframes. These days also it is possible through desktop virtualization. So let's now look at how is this possible. I mean, practically how can we do it? So let us have a quick look at VMware Workstation. I mean, this is what the case study we have for today. VMware Workstation is a hosted hypervisor. As I said, there are 2 types of hypervisors. One is bare metal, the other one is hosted. So in this case, let us have a quick look at VMware Workstation. VMware Workstation is a hosted hypervisor which can enable users to create multiple virtual machines on whatever physical infrastructure we have. So we can run multiple virtual machines simultaneously. We can start them, stop them, migrate them, we can do everything. And every VM can run its own operating system. It can have its own platform. And you can provide network-like functionality also among all those physical resources. So it actually mounts an ISO image, your installation, platform installation or operating system installation file. It is known as ISO file, ISO image file. So it mounts it as a VMDK, virtual machine disk file. So using this you can create multiple virtualizations, multiple virtual machines. So this document will walk you through the sequence of steps that you need to perform. This is bare minimum. I mean, you can create multiple things, but in this case I just listed down some of the important steps that you need to perform to create a virtual machine on top of your physical computer. So this is how your workstation, VMware Workstation console looks like. So you can create a new virtual machine. So when you click there, it takes you to a wizard where you can customize your virtual machine, or you can typically follow the recommended version, and you can specify the ISO image, what kind of ISO image you want to install, what kind of operating system you need. So you can go for Windows 7, you can go for Mac OS, you can go for any other ISO image you have. In this case, I've taken CentOS for illustration. CentOS is a Linux version, and you can give all the details that you need, whatever the username, because when we have a Linux machine, you need to give the administrative username and password details, and then what is the virtual machine name, and where do you want this virtual machine disk file. As I said, your virtual machine is created in a virtual machine disk file. So where do you want this BMDK file stored? So you can give the location where it can be stored, and you need to specify the storage. So how much storage do you want to allocate? You may have 1 terabyte of hard disk. You may not want the entire 1 terabyte of hard disk to be used for this virtual machine. You may need some less space. So in this case, I've taken 20 GB. This is the default value. You can change it if you want. And this is a typical summary of what we have selected, because most of these options are automatically selected. So 20 GB hard disk, 1024 megabytes of RAM. You can increase it if you want. And network address translation, because in this case you may have multiple virtual NICs, virtual network interface cards, but you have only one physical network interface card. So how does the communication happens? So network address translation will take care of all those things, so that it automatically converts your incoming traffic and route it to the appropriate virtual machine. Your hypervisor is responsible for doing that network address translation. So you can customize the hardware if you need. You can select. So this is how it looks like. So memory, you can increase it if you want. It should not be beyond your physical memory. For example, your physical memory is 4 GB. You can put it up to 4 GB. You cannot put it as 8 GB. And number of processors you need, and number of cores in the processor you need. Typically, if it is a dual core processor, you can put it 1 processor and 2 cores. If it is a quad core processor, you can put the number of processors as 1 and cores as 4. And if you need any CD, DVD, you can put it, so you can operate it. Network adapter, it's network address translation. USB, you can virtualize, you can put it. Sound cards, printers, everything you can attach to this virtual machine. So once you specify all those details, you just have to click finish. And then virtual machine, this will take a few minutes to create because it has to copy all the libraries. Since it is a Linux version, it has to copy all the library files that are needed. So it copies all those things. As you can see, starting package installation process, it takes, based on your processor capacity and memory, it may take 10 to 15 minutes time to complete the process. Once it is successfully created, you can log in. So this is my virtual machine. So on Windows, I have one Linux machine running. Likewise, I can run another Linux machine. I can run another Windows machine. I can run another Mac OS virtual machine. I can run another router, maybe a typical router virtual machine. So you can access as you need it. So this is a brief illustration of creating a virtual machine using VMware Workstation. Likewise, you can use any of the hosted virtualization tools, hosted hypervisors such as Oracle VirtualBox, Microsoft Hyper-V, Microsoft Virtual PC. So all these things can be used to create hosted virtual machines. So far we've discussed about virtualization. The next topic is how we can use this virtualization to create infrastructure as a service. Essentially, why are we using virtualization? To create virtual resources. So how do you use your virtualization to create virtual resources over internet? because if you look at the cloud computing definition, what we've discussed that it is on-demand network access. So we should be able to provide access to these resources over internet. So we should be able to know how to provide these virtual resources over internet. So there are several organizations involved who are providing infrastructure as a service, and Amazon is a very popular one. Amazon Web Services, Microsoft, Oracle, these are all there. So let us have a quick look at some of the basic concepts of infrastructure as a service with a brief case study on EC2. EC2 stands for Elastic Compute Cloud. So infrastructure as a service. So it delivers your computer infrastructure that includes your storage, memory, processor, network, everything. Typically a platform virtualization environment as a service. So as you can see at the bottom picture, you have all these computing resources, storage, network, computing system. On top of that, you have your virtualization layer, which is providing virtual resources to the end user. So in this case, if you want to provide virtual resources, virtual machines over internet, you have to use a bare metal hypervisor, because you do not have any physical, you do not know where the physical server exactly is, so you cannot have an operating system. You may have an operating system, but bare metal is very popularly used to provide infrastructure as a service over internet. So IAAS provider, so what should an IAAS provider, an infrastructure as a service provider needs to do? He has to take care of, he or whoever it is, so the provider has to take care of the infrastructure related complexities, because if you look at the cloud computing definition again, so we should be able to rapidly provision and release resources without any interaction with the service provider. So it is the responsibility of the service provider to take care of that. So I may need 64 GB of RAM today, physical memory today. Tomorrow I may need only 16 GB. So I just change my configuration. It should automatically be done. I don't call my service provider and ask him to change this. It should be automatically done. How does it happen? So it is the responsibility of the IAAS provider to take care of all the infrastructure related complexities. So, and at the same time, provider has to provide all the infrastructure related functionalities. Quality of service is essential, and more importantly, it is based on pay-per-use model. Cloud computing is based on pay-per-use model. So whatever we use, we pay for only what those resource accesses. We do not pay nothing more. We don't pay anything more, anything less. We only pay for what we use. And so the provider has to provision all the resources dynamically based on demand. So, and at the same time, sometimes I may not even tell. I may only specify certain features. So if my CPU utilization is beyond 80% for 5 minutes, I may need more resources. So I tell only that thing. So obviously it is the responsibility of the provider to take care of all those things. As I said earlier, so these are the popular providers: Amazon Web Services, known as AWS, Microsoft Azure Cloud. This is from again Microsoft Windows Azure Cloud, it is known as, and Oracle Cloud. So the list is not complete yet. There are so many players involved, like Rackspace, all those things, to provide infrastructure as service. So let's look at Amazon Web Services quickly. So Amazon Web Services is the largest infrastructure service provider, and in fact it is 10 times bigger than the next 9 competitors in the list. So that's the kind of infrastructure they have. So it provides all types of infrastructure related services, such as computational resources like your platforms, and storage services, database services that include your SimpleDB relational database services, NoSQL databases, and queue services, notification services, and MapReduce services for providing big data and analytics functionality. So all these things, and your artificial intelligence platform is there. So it has a very big list of services it is providing on infrastructure related thing. In fact, it is providing platforms also, but our discussion is only to look at some of the computational resources. So this is the architecture of AWS. This is a very brief architecture of what AWS is providing. There are so many things AWS is providing. So you have Ec2 Instances. So Ec2 stands for Elastic Compute Cloud, which is the set of computational resources or platforms using which you can create. And you have the rest of the things which we have already discussed. S3 stands for Simple Storage Service, to provide storage-like functionality. And Simple Queue Service, SQS stands for SNS, Simple Notification Service. All these things are provided by AWS. So how do you manage? Because with minimal management effort from the user without any service provider interaction. So how do you do it? So in order to manage your resources, you need some console. So that's why we have an AWS Management Console, and you have these are the list of infrastructural resources, basic infrastructural. There are so many things available to manage your resources, your virtual resources. So you have a management console, you log in there, you manage your storage services, you manage your monitoring tools, you manage your load balancing. We have the next topic on load balancing. So you can look at your dashboard on the health of your services. You can import your virtual machines, you can export, you can import your data, export your data, all these things, because mostly we have on-premise cloud and this is a public cloud. So we may need mechanisms, suitable import export functionalities to export the data from your on-premise cloud to public and vice versa. So to do it, it should be able to provide necessary tools, and AWS has all the necessary tools to do it. So today's discussion is specifically about EC2, Elastic Compute Cloud. There are so many things, but due to time restriction, we are discussing about only EC2. Amazon EC2 is the infrastructure provisioning cloud service. As I said, infrastructure provisioning cloud service, essentially it provides platform-like environments. Elastic Compute Cloud, EC2 stands for. So it provides web services, basically API, application program interface, or a web service, a RESTful service, representational stateful service, which you might study in your web technologies elective. So it provides a web service. Using that web service, you can specify all your details, what kind of instance you need. We have a demo also, quick demo on how to create an EC2 instance. There I'll quickly try to explain how you can access these EC2 APIs. So it provides, so how do you create all these platforms? So you have pre-computed Amazon machine images, AMIs they call. So using these AMIs, you can create your EC2 instances. So typically using EC2, you can create quite a number of instances, a large number of EC2 computing instances. They include, these are some of the categories in EC2 instances: general purpose instances, compute optimized instance, because your requirement may be different. For example, you have built you have designed an algorithm. Now you want to execute, you want to see how it performs. So it may require a lot of computational capacity, so that which may not be available. Likewise, you may want to run some big data analytics program on some huge, humongous data. So that may require your storage, large capacity of storage. So likewise, to meet all those requirements, we have several kinds of instances. EC2 uses Xen-based virtualization. In the previous topic, we have seen VMware Workstation based virtualization. So in this case, it uses Xen. As I said, it's a bare metal or type 1 hypervisor to create virtual instances. So it provides all the necessary web services or APIs to provide, to provision, manage, deprovision all your virtual services on your Amazon Web Service Cloud. That's why it is called Amazon Web Services. So these are some of the configurational details about various instances. So 64-bit platforms, computational instances. So minimum, the medium one offers 3.75 GB of virtual memory and one virtual CPU, 4 GB of storage. You can see M3.2 extra large, it offers 30 GB of memory. 30 GB of memory is really costly. If you want to buy it, it may cost some thousands of rupees or even lakhs of rupees. But this is possible at the rate of 3 cents per hour. 3 cents is essentially, I think, if you say dollar is 70 rupees, 3 cents is around 2 rupees per hour. So per day you are spending only 48 rupees to access that. And more importantly, you can do away with it when you do not need it. You may not need it for one full year. You may need it only for a few days just to test your algorithm. You may need it for a month or so. So similarly, compute optimized instances. Compute optimized instances offer more memory, more CPU capacity, 32 virtual CPUs. It's like a cluster, 640 GB of storage and 60 GB of memory. And memory optimized instances, see, as you can see, 244 GB of memory, 32 CPUs, and 10 gigabyte Ethernet cards. So this is some of the configurational details. You can see many, in fact. There are so many things because I've listed down only few here. And storage optimized. You can see 8 into 800 gigabytes of storage. How much is it? It is 6.4 terabytes of hard disk data. And you have dense storage instances, 244 GB of memory, 24 into 2 terabytes. So 48 terabytes of hard disk storage. So which is not possible. You cannot buy these things. They are very expensive. They are getting provided over internet. So that is the beauty of cloud computing, and EC2 is making it possible. So EC2 allows, basically it bundles operating system, your application software, your libraries into an image called Amazon machine image. So it's like an ISO file. It combines all those things into an Amazon machine image. Using that Amazon machine image, you can create your own EC2 instance. There are pre-computed. You can also create your own Amazon machine image and host it. Okay, so these are all pre-computed Amazon machine images. So you can use them as is, or you can probably create your own Amazon machine image and then create an EC2 instance on top of that. So as you can see, you can use these AMIs to provision multiple virtualized instances as well as decommission them when you do not need it using a simple web service call. You don't have to do anything else. You just have to make a simple web service call. On a button click, you can do all these things. You can rapidly scale them up and scale them down. That is the next topic. We will see auto scaling and load balancing. So these are all these instances. Most importantly, when you own your physical resources, what you can assure is your fault tolerance. So availability is more important, right? So you provide 99.99% availability. It does not go down. Even if it goes down for maybe it's 5 minutes or so. So your mean time failure is pretty less, because you own all the physical infrastructure. But in this case, you are not owning it. You are not the owner of your physical resources. Somebody else is in control of them. But still, all these things are provided virtually. So then how do you ensure fault tolerance and high availability? That is the reason why EC2 is organized into various regions, and each region has a lot of availability zones. So you can ask high availability for your EC2 instance so that it is replicated in multiple regions, in multiple availability zones to provide high availability and fault tolerance. So basically, another important thing is you are accessing all these virtual resources over internet. So when you say when you are accessing over internet, it must have an IP address. So what kind of IP address should be? It should be a public IP address, because you are accessing it over internet. It should not be a private IP. If you are accessing it in a local area network, then you can assign a private IP, but it is being accessed over internet, so it has to have a public IP. So generally it is a dynamic IP address which automatically assigns it, but sometimes you may need a static IP also, so that you do not need any changes, because when you shut down your instance, when you bring it up, a new IP address is assigned automatically by a DHCP, Dynamic Host Configuration Protocol server is there, so that automatically assigns it and it configures the DNS accordingly. But in this case, in some cases you may need a static IP to be allotted. So in that case, we have a concept called elastic IP. You can assign elastic IPs also. At the same time, storage. So where do you have all these storage? So there is a separate service called simple storage service, where your EC2 related storage, your hard disk or SSD solid state drive data is put into your S3. It is organized into buckets, and your simple storage service will take care of all the storage related activities. So another important thing is it is a virtual machine. So if it is a physical machine, you can put a password so that only authorized people can access it, but it is a virtual machine which is accessible over internet, and there is a public private key configuration is there which you can access, but at the same time you may need to provide more security to it. So maybe others should not be able to send any traffic to it, others should not be able to access that network, that web server running on it. So how do you do it? So there is a security group where you can specify all the rules. So what kind of protocol is allowed on that machine, so what port can be accessed, all these things you can specify in the form of a CIDR notation, classless interclass dynamic routing notation. So you can specify all those things to provide port level access as well as protocol level access. So this is again a default security group. You can specify, you can allow access to all the resources or the entire everybody can access your virtual machine. So you can put all those rules, up to 500 rules you can specify. So example security group looks like this, as you can see. So this is default thing, all ICMP, Internet Connection Message Protocol, which is used for pinging. So when you say default group, everybody can access it. TCP, all the ports are accessible. UDP, all the ports are accessible. This is the default group, but this actually puts your machine at risk. because people can send a lot of traffic to it, so eventually you will be attacked with a denial of service kind of thing, or your system may go down, your virtual machine may crash. So this is a default group, but you can, right. So this is again security group. You can put a protocol kind of thing, whatever pre-configured instances, all these things. So this one will tell you the HTTP. So you can access, anybody can access. So the CIDR notation 00000/0 tells anybody can access your web server from anywhere. So that's how you can put it. So this is the instance architecture. So this demo will walk you through how to create an EC2 instance quickly. So this is the AWS Management Console. So this is how it looks like. So you can click on launch instance. You can log in your credentials, log in using credentials. You can click on EC2, launch instance, and then you can select, as I said, pre-computed Amazon machine images. You can select, in this case I've selected Amazon Machine Linux. You can select the type of machine you want to create, medium capacity server or major capacity server or tiny server, anything you can, you have to specify certain other details. Details such as all the name of the server, how much capacity you need, 8 GB. In this case, I've selected only 8 GB general purpose solid state drive. So you give some name, so it automatically, and you can create security group to it. So, and you can access it. So once it is done, once you give all those details, you need to give a public key, private key file. So you need to download a permission file, so which is used to create a private key as well as a public key. Using private key, you can connect to that instance. So that instance, so this is how your machine is created. So it is running, you can access it, and this is created in northeast of US. So this is the availability zone where it is created. So you can connect to it. So you have to generate all these public keys and private keys. Using public key, you can connect to it. So this is how it looks like once you connect to it. So this is the private IP, and you can have a public IP also to it because you are accessing it over internet. So this is not, I don't have any physical infrastructure with me, but still I am able to connect to it. So I can perform all those activities, whatever I want. I can install a GCC compiler, I can install a Drupal platform, I can do all those things. So this is about EC2 instance creation. So now the previous session quickly talked about the EC2 instance creation, Linux instance creation. Similarly, we can create a Windows machine also, but in this case, in the case of Windows, you will have a remote desktop client, RDC file, using which you can connect to your Windows machine and access it. You can connect to it via your mobile also. That's the beauty of infrastructure as a service. So the next thing is load balancing. So you may have, because when you have, what are we talking about? We are talking about cloud computing to rapidly provision services. So increase your resources on demand. So how do you do it? So you need to be able to first balance your incoming traffic. For example, you may have 4 servers and you have 10,000 requests. Do you route all those 10,000 requests to one server? The server may crash. So it may not withstand the incoming traffic. So you distribute it. So you need a load balancer which can distribute your incoming traffic across all these servers. So load balancing is essentially the process of distributing incoming application or network traffic into multiple targets. They can be servers, your IP addresses or networks, anything. So what does it do? It ensures high availability, because one server may not handle 10,000 requests, but 4 servers can together handle it. Maybe one can handle 2,000, another can 3,000. So your request will be served. The end user doesn't know which server is handling it, because the load balancer will take care of that. So this provides high availability. in fact, we call it as rapid application cluster in database technology in Oracle. So similarly, in load balancing conceptually distributes your incoming traffic across multiple servers. So it can dynamically add or remove servers. For example, you have only 2000 requests, so it doesn't need to distribute 2000 requests to 4 servers, because it unnecessarily puts overhead, the processing overhead. So it can route all those things to one server. The remaining 3 servers can sit idle. And load balancer will automatically monitor the health of your overall IT infrastructure, IT architecture. So if you have 4 servers, it monitors which servers are working fine, which servers are actually having more CPU utilization, or which are not working, which are not healthy. So it may not send any traffic to those servers. So in Ec2 also we can perform all these things using a concept called elastic load balancers. It is also known as ELB. So elastic load balancer, it distributes, again, the basic concept of load balancing. It distributes incoming network and application traffic into several Ec2 resources. It can dynamically detect it. In fact, you don't have to do anything as an end user. You don't have control, or you don't need to do anything from your side. It is the responsibility. You define an ELB, the ELB will take care of which are working fine, which are unhealthy. So it automatically stops sending network traffic to unhealthy instances, and it can send only to the healthy instances. It can be attached to a security group. As I said, it can be attached to a security, because load balancer is a sensitive one. So not everybody should be able to access it. Not all the systems over internet should be able to access it. So you can attach a security group so that only authorized IP addresses can access it. So it can use either layer 4 specific or layer 7 specific features to load balance. I mean, either if you want to distribute network traffic, you need to define it at layer 4, because that is the transmission control protocol layer. If you want to route your traffic at the application layer, you need to put it as a layer 7 specific load balancer, so that your application traffic will be routed. So how does it monitor the health of the instances? There is a separate tool called CloudWatch in AWS, which will send metrics regularly to this load balancer, and using those metrics, load balancer will perform the activity of load balancing. So it typically provides 3 types of load balancers: classic, network, application. As I said, classic load balancer is distributing your traffic, which can be either network traffic or application traffic, across Ec2 instances based on certain metrics that you define. Network load balancer, it only talks about the layer 4, the TCP, transmission control protocol layer, TCP layers network incoming traffic. So it looks at the network packets, IP packets, and then based on that it will route it to the appropriate network. Application load balancer, this actually looks at the application data, and then accordingly it routes it to the appropriate server. So basically these are the features: detection of unhealthy instances, spreading instances across multiple healthy channels, and centralized management of your security, SSL certificates or TLS, transport layer security. So classic load balancer, this is how it looks like. It provides basic load balancing across multiple Amazon EC2. As you can see, so load balancer, if one instance is not working fine, it can send it to other set of instances. It normally operates at layer 4. It normally operates at layer 4, but you can sometimes you can define it at layer 7 also. So network load balancer, it looks at your network packets and then route the data, route the network traffic to various EC2 instances defined under a virtual private network. It is also known as virtual private cloud. So you put all your EC2 instances into a set of networks. So you may want to route your network data into different virtual private networks. So to do it, you need to define it as a network load balancer. In fact, classic load balancer is more popularly used. And application load balancer, it looks at your HTTP requests, HTTP header data, and based on that it will route it. For example, you may want to send all your /API. For example, if your URL includes /API, they might be routed to some application server. If you have /mobile, they may be routed to another group of EC2 instances. So it looks at, it's a content based routing basically. The first two are network layer 4 related, they look at network packets, but this thing looks at only the URL part. So looks at the actual content of the URL, and then accordingly it will route it. So CloudWatch, as I said, all these load balancers work on the metrics provided by CloudWatch. So auto scaling, basically load balancer is only distributing. So you need to dynamically increase your resources, dynamically decrease your resources. So increasing and decreasing resources is called auto scaling. So auto scaling is possible using EC2. Auto scaling, for that you define a set of resources and metrics. For example, if your CPU utilization is more than 80%, you may want to increase your resources. So the bottom diagram explains that. So your minimum size, number of instances is 1. Your desired capacity is 2. When something is going wrong, when network load is very high, your traffic is very high, you may want to increase it to 4. You specify all these minimum number of instances, maximum number of instances, desired capacity. Accordingly, your resources will be automatically scaled up and scaled down based on certain metrics. For example, if your CPU utilization is more than 80%, I need a resource to be created. If it is below 40% for 5 minutes, you reduce 1 instance. So automatically it gets created, automatically it gets decommissioned. So that is the beauty of auto scaling.